Hi, my name is Trey Hayden, and for today's video I wanted to go over a slightly obscure topic from the Unity animation system, and it's Animator state behaviors, and how I use this particular feature to solve a few problems within my own projects. For this video I'll be using an animation from Mixamo, which is an online database hosted by Adobe for free, where you can download Unity-friendly animations directly into your project, and they're kind of up and running in seconds. So if you need an animation for a particular situation, Mixamo is a great resource. The only stipulation is that you can't sell them as your own. I think everything else is fair game, but don't quote me on that, I'm not a lawyer. For the assets from the asset store I'm using, these are all free. First one is just a particle pack community, just a generic explosion and a little sword effect I want to use. Then some sound effect for steps and the little explosion sound effect. And then this little chibi character here of the lady with the sword. Other than that, this is pretty simple tutorial code. Pretty run-of-the-mill, everything's just going to be in one script, and nothing here is particularly important. So the project for today is going to be this little knight lady who's going to be running around, and all she can do at the moment is cast a spell. So we have the spherical camera system from second video, we have the particle event system from third video, so we know how to do all of this stuff so far. And what I would like to happen today is that when she does this, that we have some way of preventing her from receiving any further action until this casting animation is done. And there are a few different ways you can go about solving this. You might be playing the animations explicitly without any transitions using crossfade or something. You might be using some sort of state machine and having some sort of delay after the casting animation, say, okay, after some arbitrary delay that I maybe hardcode or derive explicitly from the animator itself, then you can resume animations. And I haven't been a big fan of any of these approaches so far. And the one I've been gravitating more towards in the last few years is this notion of a state behavior, whose job it is to sort of send a message to the player from the animation side to say, hey, an important animation is playing. You might be already input blocked by UI or some sort of cutscene or some other external factor in the world state. But in addition to that, I want you to be blocked as a result of the animator. And so that's what we're going to do today, is we're going to implement a state behavior on this casting node. We'll send a message to the animator side. The animator will receive it on a mono behavior there, relay that to the player, and then undo that through a similar process. This way the player knows, okay, there's something in the animator that does not want me to receive input. I must yield until this is complete. And then once that's resolved, I will have control again, and we can continue kind of playing the game. Okay, for the actual implementation of this, let's go ahead and start with the state behavior side, since that might be a little more interesting than connecting all of the events on the mono behavior side. So if you've ever selected a node within the Unity animator system, you've seen this kind of inspector here on the right, where there's an animation that it wants to play, stuff like animation speed, if you want to parameterize any of this stuff, etc. And then there's this button here at the bottom for add behavior. This is very similar to the button for adding something like a mono behavior, another component to a game object, and that's how we're going to use it. So we're going to click this, and remember, I want some sort of component here that will send a message to the animator so that some component next to the animator can receive it and then inform the player of, hey, there's an important animation playing, you aren't allowed to give input to the player. So for this one, just for the tutorial sake, I'm just going to call this send busy messages. And when we go into this thing, when I first opened this, I was a little intimidated for learning this feature, because there's a bunch of stuff commented out, and honestly, if you uncomment it, it's kind of clunkily not C# friendly. But these are the 5 messages, the only 5 messages actually that can be received for a state behavior. It's stuff when the state is entered, while the state is active. This is essentially the update here. When you leave it, and then stuff like if you're moving or if you're doing some sort of inverse kinematics. So of these 5 lifecycle calls, the only 2 that we're going to use here are onStateEnter and onStateExit. And this is going to be so that we can send information to the player that an important animation has started and stopped. I'm going to do this through send message. So I'm going to have one for on animator busy and on animator available. We're going to send these on the entry and the exit for the state. If you don't like doing this kind of approach where using send message for this, I don't blame you. I don't really like it either. But after I implemented it for a couple of projects, no one threw a brick through my window. Mom didn't call and tell me that I'm a terrible person. Everything still kind of went on just fine. At the end of the day, it's your project. Use what you do like and avoid what you don't. But just try to keep an open mind that even though something might not seem particularly savory to you and your preferences, it might still come through and be of some use at some point during your kind of game dev journey. So if I go back over here to our Unity window, so currently the way I have my player set up for this little tutorial project is that the player is this kind of thin object that's just sitting by itself with the main player component, and then the visuals are children. So the animator is considered a visual since this kind of controls animations and stuff. So this is its own object beneath the player, and capturing all of these sort of animation events is a special component I've called player animation hooks. So as we saw at the start, this is already capturing things for the step, and if there's a cast getting ready, and when the cast actually releases. These animations are then, well, the animation events are then emitted through public events, which are then subscribed to by the player, and then the player goes on and does its business. So we're going to do the same sort of thing here. I'm going to add 2 new public events here. Action on Animator busy, and on Animator available. So this is going to be busy. We're going to type this a good bit, so it might be a little bit repetitive. Invoke. And on Animator available. Invoke. Okay, so this is here now. So I'm going to go back up to my player. So here, during the awake is kind of where I'm subscribing for the stuff. So I'm going to add 2 new things here. For on Animator available and on Animator busy. Animator available. Okay, need to add 2 stubs for these because they don't exist right now. And for exactly what these functions are going to do, so what we're going to have here is just an extra flag for private bool animator busy. And all these are going to do is just set this flag. So if it's busy, animator busy equals true. And if it's not, they're busy equals false. Simple. So for my setup right now, we only have this kind of Boolean flag here, which is fine for this one since we're not using any animation layers or anything. But if you are using animation layers, or you have some kind of goofy setup with either blend trees or some sort of crossfade situation where multiple things might be calling these busy and available functions at the same time, you might get a confliction of some sort, then you may consider having some counter that just says this is the number of busy requests I currently have, and then evaluating this, flag to be, okay, do I have more than 0 busy requests? And then kind of resolving it that way. So you might cut down on conflicts, but again, in this case, we don't have that situation, so we're just going to use a flag. And then down here for the update, what I'm going to do is say, okay, if we're currently busy animating, we're busy, then not going to allow movement or weapon input, but we're still allowing the camera just for kind of general quality of life. So let's go back over to the project. And if everything worked out correctly, you can still move around, that's fine. And when I do this, I can move the camera. Can I move? No. I can't submit any additional requests. And it seems like things are working for the time being. So that's good enough for this project. So I'm going to go over to a few of the other ones where I've used state behaviors in the past and sort of show a few examples of how those are working in a more involved project. But to recap here, so our use case was we went to stop animation inputs and general movement inputs to the player as long as this particular state was active. We did this by adding a new state behavior for sending busy messages. This message is then sent to siblings of the animator. We captured that here, and this one called player animation hooks. This is subscribed to by the player script itself through C# events, just traditionally. And then the player controller blocks input to movement and actions once it determines that a busy animation is playing. So for the first of the 2 kind of real-world projects, I'm going to show the Quest 4 remake effort from the previous video. If you've played the original, you may have noticed that when Brian moves and suddenly stops, he does this kind of cute little sliding thing. But he won't do this under certain animation conditions. For example, if he's trying to open a door, or if he's opening a chest. So similar to the busy messages that we sent from the tutorial, there's an additional state behavior here for sending anti-sliding messages. So that when he starts this sort of chest animation or a door animation or something else that should also prevent him sliding and kind of lock him in place immediately, that the movement controller knows, okay, I shouldn't perform the sliding, and then the player knows, okay, I should not be relaying a sliding animation request to the animator because something is currently superseding it. Similarly, in the project code for the state behaviors, there's also one here for root motion events. If you've noticed from the original, just about every enemy in the game moves using root motion, but not every animation that I'm sort of doing for this will have root motion on it. And so what these are going to do is when one of these, root motion heavy, animations is going to play for a particular actor, this will notify the actor's sort of parent controller that, hey, root motion is available on this. You should be using that to move the character instead of traditional sort of just, navigation meshes. And the second project I wanted to show is this dive project. So if you haven't gotten to the point where you have a project that's made it to Steam and other people are playing it, then you may not be aware of how quickly your kind of best practices and restraint sort of goes out the window when you have a fixed release date in mind. So in the case for this project, there is an animator for not only the player, but also for the arms. So the holstering system for this project was a little bit involved, where instead of just the gun sort of appearing in your hand or the shield appearing in your hand, it sort of spins behind your back and it goes from this kind of holstered state into kind of an upright, arm state. And so the way I word about this, let me try to bring the animator up so it's not as tiny, is each arm has its own animator. And they use the same shared tree, but it's the same kind of thing where, if I'm currently in the holstered state for my right hand and I activate it, then it goes to the armed tree. Similarly, if I stow it away, stowed animation activates and goes away. And when I was getting this ready for kind of release, I had an issue where certain triggers for the animation would keep kind of like, superseding other ones, and I would get this goofy behavior. And so I eventually just have a state behavior here whose entire purpose is just to clear trigger parameters from the system. And if this looks goofy, then, I apologize, but this is sometimes what happens to not only just a game project, but any sort of software effort when you're trying to ship it and you just want everything to work. You're not super duper, concerned about, okay, what are the long-term maintenance requirements for this? So again, not super duper proud of this, but wanted to show a situation that was outside of the sort of clean room tutorial environment. And similarly for the player, it's the same kind of structure we saw for the Quest project, where any state is mostly going just about anywhere. But similarly, I was having an issue where the death animation was playing, and then some other action would happen, and then the player would kind of stand up as they were dying, and it would look kind of goofy. And so what I ended up doing for this was, once the death state is entered, it sets a bool on the animator itself for dying, and then every single other transition here from the any state that could be triggered by external factors has a condition on it that must have dying as false. So again, maybe you can relate a little bit if you've been trying to ship something and you keep getting stuck on seemingly small animation bugs or something. But this was another condition where I thought, you know what, I'm just going to use a state behavior for this. I can't find in my state machine where this is happening, but I definitely want to make sure that, the death animation doesn't get interrupted and the player stands up, because that looks kind of goofy and amateur. And at the end of the day, as long as the player has a decent experience, I'm not super duper concerned with how hideous the animator eventually became. And, with my own shame of having to do this very goofy dying conditional check for the animator, because again, it did end up working just fine. So those are the only two I wanted to show for today. If you haven't seen state behaviors before, hopefully you're a little more comfortable with them now. If you don't have a use case for them in your own kind of personal project, then don't worry about it. Again, you don't have to do everything, and if this ends up being somewhat useful for you, then go for it. But otherwise, hope you have a great day, and best of luck in your game dev. Bye.